Time appropriate greetings everyone and welcome back. In this video we're going to use exponential smoothing to make forecasts. We'll use different smoothing constants and then use the mean squared error to choose which smoothing constant best models this data. Consider the daily closing price for Apple stock over the 1-year period spanning April 25th, 2019 to April 24th. Let's use exponential smoothing to make a forecast for April 27th, 2020. We're going to use exponential smoothing to make a forecast for April 27th, 2020. Note that April 24th is a Friday, so April 27th is simply the next business day. Again, we're going to use exponential smoothing. I have the formula written here. Using exponential smoothing, the next forecast, f of t plus 1, is a weighted average where the previous day's observation is given the weight alpha, and the previous day's forecast is given the weight 1 minus alpha. So we're going to make this forecast using alpha equals 0.1 and alpha equals 0.3. These are the two smoothing constants we're going to use. So for 0.1, yesterday's observation will be given 10% weight, and yesterday's forecast will be given 90% weight, 1 minus 0.1. Since exponential smoothing is a recursive forecasting technique, it needs a forecast for the first day. I'm just going to use the first day's observation, 205.28, to also be the first day's forecasted value. Let's start computing these forecasts with the smoothing constant 0.1. We'll choose the second day, and we need to give 10% weight. I'm going to do a reference here, and I need to give that 10% weight to yesterday's observed value. So 10% of the observed closing price. Then I'm going to add 1 minus 10%. Notice that I'm not hard typing any of these numbers in, but that's going to become 90%. And I'm going to multiply that by yesterday's forecasted value. 10% of yesterday's observed plus 90%, 1 minus 10% of yesterday's forecasted. I'm going to want to autofill this formula down to the rest of the days. When I do that, I want the observed one to move down with it. I want the forecasted to move down with it, but I do not want the reference to this 10% to go down with it. So I'm going to put a $sign in front of these two tens so that when I move this autofill down, it's not going to pull the row reference down with it. It's going to stay in row 10, this reference to alpha, to 0.1. Hit enter. Of course, this forecast is going to be exactly the same as day 1. Don't be alarmed. This is just because the forecast and the observation were the same. I am now going to autofill this down to the bottom. And we have a forecast 271.49. That's in cell D264. I'm going to make a reference to that up at the top. And notice again, just because I fixed that row reference on the D10 here, when I moved the formula down, the reference to the smoothing constant did not move. Let's compute the squared errors for all of these. So we take the observed value minus the forecasted value and square it. That'll be 0 for day 1 because they're the same. There is no error. I'm going to double click this to autofill it all the way down to the bottom. Now let's average these squared errors to compute the mean squared error. I'm going to stop the average at day 253. There is no observation for day 254, April 27th. That's what we want to forecast. So there's not going to be an error that makes sense. I'm going to delete this cell in 1 second. It's going to go down and delete that last squared error cell. Doesn't need to be there. And we compute that the mean squared error is $162.87. Now let's compute the exponential smoothing forecast using a 30% smoothing constant. So this time we get 30% weight on the previous day's observed value. Instead of 10% weight, it's 30% weight on that 205. And then we're going to add 70% weight, 1 minus 30%, to the previous day's forecast value. Now the forecast will be living in this column, whereas the observations are still living in column C. Again, I need to fix those references to the exponential smoothing constant. We need to fix the row that they're in. And we hit enter. 205.28, again, it's going to be the same as the first day because the forecast and the observation were the same. Double click to autofill this all the way down. We'll clean up anything at the bottom soon. We'll compute the squared error here. We have the observed closing price minus the forecasted closing price. Square that. It's 0 in the first day because they're the same, just like the 10%. Double click to autofill this. Let's scroll all the way down. Delete this squared error because, again, there's no observation for day 254, so there is no squared error for day 254. And we have our new forecast for day 254, April 27th, 277.83, a little higher than the 10% smoothing constant. This is in cell F264, let's remember that, and put it here. And we can compute the mean squared error for the 30% smoothing constant by selecting all of the squared errors for 30%. The mean squared error for alpha equals 0.3 is 58.04. So on average, using 30% smoothing constant provides a closer forecast to what we actually observed. Since exponential smoothing with alpha equals 0.3 has a smaller mean squared error than using 0.1, we're going to make the forecast using alpha equals 0.3. It's the closest forecast of these two. So I predict that on April 27th, the Apple closing price will be $277.83.